Okay, so the first thing it's going to ask you is find the first 5 terms of the sequence. We know these are the easy ones, so all you have to do is plug in. You're trying to find a sub 1, a sub 2, a sub 3, a sub 4, a sub 5. So you just plug in a 1. So this would be negative 2 times 1 squared, which is negative 2 times 1, which is negative 1, right? You just plug it in. You plug in 2. Negative 2 times 4, because 2 squared is 4, is negative 8, plus 1 is negative 7. And then negative 2 times 3 squared, 9 times negative 2 is negative 18, plus 1 is negative 17, and so on. Right? First 2 problems on the test, super easy. Huh? Yeah. Okay. Second part of the test says write an explicit formula for each sequence. You have to decide, is it arithmetic or geometric? So this one is arithmetic, and then you'll have the formulas. So you'll say, okay, you'll look at the formulas on the back of it's on the back of the test. So the explicit formula for arithmetic is a sub 1 plus n minus 1 times the common difference. So we do 2 plus n minus 1 times, my voice is so bad. Oh, I'm miserable. Times 2. Right? Now to get the full point, you're going to want to simplify it by multiplying 2n minus 2. Combine like terms, so those 2 happen to cancel out. So our final answer would be a sub n is equal to 2n. Okay, awesome. This one, you'd have to say, oh, it's geometric. I can't even listen to myself talk. It drives me insane. Times by negative 2, times by negative 2. Now make sure, because they're not going to all be this straightforward, like how do we find what we're doing, if we're adding or subtracting? You do this divided by this, right? Because you're going to have decimals. This divided by this. This divided by this. It's negative 2. So you say the common ratio is negative 2. The explicit formula for that is a sub 1, because it's geometric, times r raised to the n minus 1. So you would put 2 times parentheses negative 2 raised to the n minus 1. That would be your final answer for that. Questions? Easy. Okay, now next one on the test, we'll say find the 12th term of each arithmetic. Now, it makes it easy because it tells you it's arithmetic. Find the 12th term, so you just plug it straight into the formula. So that'd be a sub 12 is equal to a sub 1. It's arithmetic, so negative 2 plus, oh my gosh, my voice. You guys, I'm so sorry. 12 minus 1 times, what's my common difference here? Let's say we don't know. You do this minus this, which is, you're right, 3. And then you would just calculate it for this. Type it in your calculator. All good? Okay, I'm going to hurry and type that one in. I don't have to think. Negative 2 plus parentheses. Okay, thanks. So a sub 12, our 12th term is 31. Okay, awesome. Okay, find the 8th term for each geometric sequence. Once again, it's making it so easy because it tells you it's geometric. This is find the 8th term, so you would do a sub 8 is equal to a sub 1, which is negative 7 times, what's our common ratio? This divided by this divided by this, isn't it negative 2 raised to the 8 minus 1. Why? I swear it's like somebody's trying to make us not do this really long video. Okay, negative 7 times negative 2 raised to the 7. So a sub 8, our 8th term, is 896. All good? Okay. Okay, next part of the test will say find the sum of each finite arithmetic series. So notice they tell you straight up it's finite and it's arithmetic. So you use the sum formula. I'm going to give you the formulas. You're going to flip to the back of your test, and it will give you the sum formula. So first of all, remember that for the sum formula, you need to know the number of terms you're summing up. So with arithmetic, it's pretty easy to find. We need to know what this is, correct? What term that is, because then we know we're summing up 10 terms, for example. So once again, let's figure out the difference. 52 minus 7. There's 45 in between 7 and 52, but we're not working in ones. We're jumping in threes, aren't we? So divided by 3 is 15. Divided by 3 is 15. But make sure you say, okay, so we had to add 3, starting with 7, we added 3 15 times to get to 52. So that means there's 16 terms. We're actually summing up 16 terms. You add 1, right? So you'd say the sum of 16 equals 16 divided by 2 times a sub 1, which is 7, plus a sub n, which is 52, and you would just type it in. And then, because we're jumping in groups of 3. So our sum is 400. The sum of 16 terms is 472. So down here it's negatives. Don't let negatives throw you off. You do the same process. Negative 42. But you have to make sure you don't mess up on the negatives. So negative 42 minus negative 2 is negative 40. But we're not working in ones. We're working in fours. Yeah, we're subtracting 4. Now we're subtracting 4. So that means minus 4, right? You'll divide by negative 4. You'll never have a negative sum. Like you'll never have a negative n, because n is the number of terms you're summing up. So we get 10. Should I use 10? No. No, we got to add 1, right? 11. So the sum of 11, we were told this is arithmetic, same formula. 11 divided by 2 times a sub 1, negative 2 plus a sub n, which is negative 42. And that sum is going to be negative, which makes sense because we're adding up a bunch of negatives. Did you get negative 242? Okay, awesome. Okay. Then the next part says, determine if the infinite geometric series diverges or converges. This is the last problem on the front page of the test. So once again, remember, if it's infinite and geometric, there are times when you can find the sum. If it's getting smaller and smaller, eventually it's so small that it's 0, you can find the sum. You use the pretty formula, correct? However, okay, so if it's getting larger and larger, you can't find the sum, just like with arithmetic. So looking at this one, is it converging or to a sum or diverging? Is it getting smaller and smaller? It's infinite. We don't know how many terms to stop summing up, so that makes it infinite. But because it's getting smaller and smaller, we can't find the sum. So you say it converges. And because it converges, you're going to use the sum formula, the easy formula. So S is equal to a sub 1 over 1 minus r. Our first term's 5. Divided by 1 minus. If you don't know your r, do this divided by this divided by this. 2.5 divided by 5 is, what is it? Yep, it's 0.5. So your common ratio is 0.5. So you do 1 minus 0.5. So type it in. 5, your parentheses need to be there on bottom. 1 minus 0.5. And we get 10. It literally adds up to be 10, you guys. It's cool, yeah. Okay, this one is geometric, correct? 18 divided by 6 is 30. 6 divided by 2 is 3. It's infinite. Isn't it getting larger, though? We're never going to know when to stop adding, so it diverges. I sound like a squawking bird. Diverges. Okay, all good. Okay, cool. Now, with this one, it says find the missing term of the arithmetic sequence below. There's many ways to do this one. You can set up a true statement. So wouldn't it be true to call this x? This minus this equals this minus this, correct? That's one way of doing it. Or you can find the arithmetic average, which is what we just did when I said this minus this equals this minus this. Because we want to know the halfway distance, correct? Because it's split evenly. So you do 48 plus 16 divided by 2. Plus 16 divided by 2 is 32. So this is 32. Everybody understand? Now, it's different if it's geometric. Okay, so if it's geometric, you put an x in, and you have to set up a true statement. This divided by this is equal to this divided by this. If it's geometric, you have to do it this way. Negative 50 divided by x equals, and everybody missed this on the test we already did. You missed part of it, so I'll explain why. Equals x over negative 2. Does everybody understand why that works? Why that's a true statement? Okay, when we cross multiply, we multiply negative 2 up, we'll multiply x up, won't that be 100 equals x squared? When we solve for x, we take the square root of both sides of the equation, X is equal to plus and minus 10 on the test. Everybody forgot to put plus and minus. Yes? That's what we just did. I mean, well, you're just doing it in your head. Yeah, but you're doing, this is why you're doing that. It's algebraic like this, yes. So do you guys, don't forget, it could be plus or minus 10, right? Because we don't know if we're multiplying by positive 5 or negative 5. Does everybody get what I'm saying? So make sure you put plus or minus 10 if you take a square root. Okay. It was you that gave me this. Just kidding. I don't know. No, it was everybody. Okay, next thing. It says Jessica must find the 25th term in the sequence. How should Jessica do this? If you put, she should just write out 25 terms. I'm going to mark it wrong. She should be using a formula, right? So she doesn't have to write out 25 terms. So you would say, well, Jessica, notice this is arithmetic. Isn't it arithmetic? Yeah. We're adding 4 each time, correct? This minus this equals this minus this. So you'd say, Jessica realized this is arithmetic. So she plugged it into the explicit formula. Stop laughing. Okay, so a sub 25 equals a sub 1, which is 2 plus 25 minus 1 times 4. And you would, that's how you would explain this, okay? All good? And then you'd actually find it. Okay. A barn has 10 animals in it, and after day 2, it has 17 animals, and day 3, it has 24 animals. If the pattern continues, how many animals will be in the barn in 8 days? Now, this one's kind of tricky because are we finding the sum, or are we just finding the 8th term? We're just finding the 8th term for this one because of the wording on this. Does everybody see how it doesn't say they're adding 7 more? Like, it doesn't, this one's tricky. It always gets people. Do you guys understand that, like, we wouldn't be finding the sum because if we find that, because it's just 7 more each time. So if we find the last term, that's going to be the number of animals. Do you get what I'm saying? So you'd say, I'm trying to find, but it just depends on the problem. That's why you've got to be careful, because remember on the test review when it said, how many total stairs did he climb? You needed to add them up. So it's all in the wording. Does that make sense? Okay, so this one, we're finding a sub 8. Is it arithmetic? Yes. Is it, we're adding 7, so it'll be the same thing. A sub 1 was 10 plus 8 minus 1 times the common difference, which is 7. Does everybody see? So 10 plus 49, because 7 times 7 is 49. I just put that in my head. Oh, 59. There's 59 animals. But if these were flights of stairs, and I said how many total flights of stairs, you would sum them all up, right? For example. So then you have to use the sum formula for arithmetic. So you would have had to know this term, the last term, correct? To find the total sum. Does everybody see what I'm saying? Okay. Okay. Okay, so to find the sum, which formula should you use for this one? Is it arithmetic or geometric? If geometric, is it finite or infinite? Finite. No, a sub 1 is this. You know the last term is this. We don't know what term that is. So you'd say it's finite geometric, so we'd use this formula, the nasty formula, I call it, which is a sub 1 minus r raised to the n, which I'll give it to you. You just have to know which one it is. You know what I mean? All over 1 minus r, and then it says find the sum. So I need to know the number of terms I'm summing up. This is the gross one, right? The one that takes logarithms. Or in desperation, list out all the terms and count them up, right? Do you want me to do it the logarithm way? Real quick. Okay, so we need to know, if we know this is a sub 20, for example, we know there's 20 terms. So we're going to try to find this. So you use the explicit formula, which is a sub n is equal to a sub 1 times r raised to the n minus 1. A sub n is 1296. A sub 1 is 2. Our common ratio is 2 raised to the n minus 1. Solve for n now. N would be the number of terms we're summing up. So my first step is divide by 2. Get rid of that. So 1296 divided by 2. 648 equals 2 to the n minus 1. Solving for n, log both sides, correct? Log base 2, log base 2, change your base formula, log base 2 and base 2 cancel out, change your base formula as log of 648 divided by log of 2 equals n minus 1. So log 648, close your parenthesis, divided by log of 2, close your parenthesis. What did I do? I got a decimal. It's because I must have accidentally, when I was multiplying this out, multiplied by something wrong. It'll come out a whole number. You know what I mean? I've multiplied it wrong somewhere in there. Like I times by 2 and then by 3 or something somewhere. Everybody understand what I'm saying? Okay, so let's pretend this came out 9. 9 is equal to n minus 1. We'd add 1. N equals 10. So now you'd say, okay, I found that I'm summing up 10 terms. So now you'd use this nasty formula. So you'd say the sum of 10 is equal to a sub 1, which is 2, times 1 minus our r is 2. Make sure that's negative. You put it in parentheses. Raised to the 10th divided by 1 minus 2 in parentheses. That's how we do it, right? Okay. Why did I put 2 right here? Because that's our common ratio. This divided by this. No, this divided by this is 2. This divided by this is 2. Does that make sense? Okay. This test is almost too easy. How do you find the missing value of the geometric sequence? Put an X there, right? We've already done an example like this. This divided by this equals this divided by this for geometric, right? And we can't forget the plus or minus. Okay. No, that would be a good question. This divided by this, because it's geometric, the only way to do it is this way. X divided by 3. So 36 equals x squared. And so x is equal to plus or minus 6. Right? Okay. Last part of the test. I didn't write this down, but I know it's on there. I swear. Just a second. Let me. If I said to you, find the sum of n equals 2 to 8 of 2n plus 3. You could just type it into your calculator, right? Or you could, if you wanted to be prestigious or whatever, you could say, okay, linear equations that represent arithmetic. So you'd say the sum of the arithmetic is s of the number of terms. 8 minus 2 is 6 plus 1. Or we're sum of 7. 7 divided by 2. A sub 1 means the first term. Plug in the lower limit. That's going to be the first thing you get. You plug it in. 4 plus 3 is 7. Plus the last term, which would be the last thing you plug in. So 16 plus 3 is 17, 18, 19, right? And then you literally just calculate it. Does everybody understand? If it's linear. So let's say I gave you this. The sum of n equals 1 to 7 of 3 times negative 2 to the 4th. To the n. Sorry. To the n. So you see how it's exponential? That makes it geometric. So you say, oh, I can find the sum of the geometric, but it's going to be the nasty formula, right? Because we know the start and end, so it's finite, so it's the nasty formula. So how many terms are we summing up? 7, right? 1 to 7. So you'd say the sum of 7 is equal to a sub 1, which is plugging in the lower, this will be n minus 1. Plugging in the lower limit, so that would be 0. Sorry, that would be 0, so that'd be 1, so that'd be 3. And then 1 minus negative 2 raised to the 7th divided by 1 minus negative 2, right? And we calculate it. Oh, it's hotter than Satan in here. Oh! Well, that one was geometric. Oh, yes. There could be. I'm trying to remember all of them. You would just type in 3 parentheses. Oh, what part? Oh, this? Let's pull it up. So everybody's calculator is a little different. But in general, how you do it on the calculator is you go like this. Okay. So So you'll go stat. Nope, you have to go second stat, over to math. Then you go to sum, and then you'll hit second stat again, over to ops, down to sequence. And then you type in the equation. So let's say that we were doing the first one, which was 2x plus 3, 2x plus 3, comma, variable x, comma, lower limit, which was 2, comma, upper limit, which is 8, close your parenthesis, hit enter, and it was 91. What? This? I just put these commas right here. Because see how this is the equation? This is the equation, right? So you type in the equation. Yeah. Yeah, that does work for geometric, yes. Yeah. So let's say, yeah, that's going to be my last example. You could. So let's pretend we have this. The sum of n equals 1 to infinity of 2x plus 1. Can I find the sum? It's linear. It's arithmetic. Can we find the sum of an arithmetic infinite series? No, right? It's getting larger and larger. We're not going to know when to stop adding. So this one we would say no sum. Does everybody understand? But let's pretend we have this. The sum of n equals 1 to infinity of 2 times 1/3 raised to the n minus 1. It's geometric. We can find the sum of infinite geometric if it's getting smaller and smaller. Aren't we going to be multiplying by 1/3 each time? It's going to get smaller and smaller. You'd say, oh, and this one you can't type into your calculator. You have to say, it's a pretty nice formula. The sum of an infinite geometric that gets smaller and smaller is this one. So then you type in a sub 1 is the first term, plug in 1, so would it be 2? So you'd say the sum of 2 divided by 1 minus our r is 1/3. And then you would just type it in. Because if you plug in, like a sub 1 means the first term, right? So we always find the first term by plugging in the lower limit. That'd be the first thing. So we plug in 1. 1 minus 1, 0. 1/3 of the 0 is 1, so we get 2. Yeah, right? Anybody confused? Okay, so then let's see what that is. I'm curious, what is that? Okay. That's literally it. It's an easy test. That was hard to test.